Hello, everyone. I am Hugo Cousillas. I am from the University of Rennes 1, and I do my research in the laboratory of ethology. And in this laboratory, we are interested in attentional processes. And that's why we developed this system of EEG recordings. And why we did that? EEG recordings, something that has been extensively used in humans for medical studies, for diagnosis, epilepsy, Alzheimer, and any neuropathology, and also for different attentional processes. We can study sleep and very high level of attention. In animals, it's less used, but all this is interesting also in animals. We can study neuropathology on animals. We can study attentional processes on animals, and it's something that we need. And why this has not been used a lot is because in human it's very easy to ask to a human to be quiet, do not move. We are going to record. You cannot do this with an animal. So most of the recordings have been done with deeply inserted electrodes in the brain. So which is something that means you need a surgery to do it. It's not very nice. Even on horses, it has been done. Until about 30 years ago, they were still doing this. Since that time, for horses, they try to do something non-invasive. So put the electrode as human on the skin. But the problem is that to do it, we need to shave the head of the horse. We need to glue the electrodes. We need to put a lot of wiring on the head of the horse. So this means that it's very complicated, it's very long to do it, and it's not very used on horses. And even veterinarians do not use it to check, for example, the anesthesia. You are doing a surgery on an animal, and you do not use this that give you the information to know if the animal is awake, or is going to be sleeping, or is going to change his state, his attentional state. So they do not use it, and the only thing that they do is to check the heartbeat, as me, the heartbeat, the breathing, and looking at the animal. And when you do it on a horse, it's very complicated. When a horse is anesthetized, he's lying down in the room, and if he starts to wake up a little bit, it can be very difficult, very dangerous. So we need something that is very easy to use it as a routine. And then veterinarian can use it easily for each anesthesia. But we need also for our studies. We are interested in attentional processes, so we need to know what is happening in the brain. So this is the reason for what we did it. So we developed this, what we call EEG helmet, to do something that is easy to use, easy to place, and fast to do it. Put it and remove it very easily. This is a prototype. We will use it, we will put it on the head of the horse. There is something very good with the horse, is that the brain is just in the forehead, between the ear and the eyes. So if you put the electrode just here, you will have the brain just under. the brain of a horse is not very big, but something like that. It's a big animal, but small brain. But the size is not the most important with the brain. The most important is what we do with the brain. This is important. So we are going to put this helmet on the head of the horse. It's only a prototype. There are a few electrodes. 2 electrodes on the left, 2 electrodes on the right, and 1 ground electrode that will be just in between the ears. With this, we can record the activity of the right brain, right hemisphere, and the activity of the left hemisphere separately. But it's a prototype, and we are going to develop more setup of this kind. So, Céline will put this helmet on the head of the horse. Céline worked a lot to do this. She is part of this project. And if you want to know a little bit more about Céline, there is a poster in the room where we have all the posters. Tu vas? And to do the contact between the electrodes and the head of the horse, she will put also some conductive cream. So you will see that it's very easy to do. And then we will see on the screen the activity, the EEG activity, and I will show you the waves that we can record. It's the most difficult part. The horse is very quiet. Now she puts the cream, and you will see on the screen the recordings. For the moment, there is no contact, so it's only noise. And you can see that on the screen, it's all moving. On the left part of the screen, on the left upper part, you have the left electrodes. Bottom left part, at the bottom, you have the right electrodes. And on the right, you have the proportion of the different type of wave that we can record in an EEG. So you can see that it's moving. She has not finished to put the cream, but on the left, you can see already that on the left, the waves are appearing. And something that we can find here, it's moving, I think, yes. You can see that in the right part, you have an histogram that is moving. This histogram is a proportion. The right part of this histogram are the higher frequencies. The last on the right is what we call the gamma wave. The second on the right is what we call the beta waves. These are the waves that we can record when someone is awake. So the horse is awake. The most part of the recording is this. Then in the middle, you have the alpha waves. Alpha wave means that if there were higher, it will mean that the horse is very quiet, almost going to sleep. Then the second from the left is the theta wave, and the last one is the delta wave. These waves are the waves that we can see when the animal is sleeping. But we can see also this when the animal is anesthetized. So which means that here the horse is moving a little bit, maybe the air, and when we can see this kind of waves during an anesthesia, the animal doesn't move. So the only thing that you will see are the waves of the brain. And if you see a little change in this proportion, if the higher frequencies are becoming stronger, this will mean that the animal is waking up. So the veterinarian will put more anesthetic product to go further. So it's something that can be very useful for a veterinarian. Sorry. So I will do something. This is all the waves are present, but we are in the case of an animal that is awake, so I will filter the very low frequencies. In 10 seconds, all will appear. And here you will see that the signal is more stable. We see only the waves from an awake animal. And in this case, we can study the attentional processes with an animal that is awake. We can do some experiments. We can, I don't know. Do you want to do it? We will see if something happens. We're trying to keep his attention. And we should see the wave on the right stronger. It's what happened. So it's exceptional, it's working. It's changing now. Still attention. She's using a laser, a green laser, a very strong one, and she is using it on the box here, and the horse take care of this. He's looking at it, and so this is something that we can see immediately on the screen. But if we do research, all these data we are recording them in the computer and then make a processing of all of this and compare different conditions. So for research it's very good, but also for medical veterinary, it's also very useful. So I told you just before that we need a system that is easy to use. You have seen Céline put it in on the head very easily, very fast, less than 5 minutes, and it works. So I think that the demonstration is good.
Thank you. Thank you very much, Hugo.